this. So in 4-76, I already did the work, so I'm just going to kind of curate it. We have a quadratic function has roots of x equals 4 minus I and x equals 4 plus I. And we know the graph of the function passes through the point 4, 1/2. Write an equation for this function. So there's there's problem, I mentioned it right up here, that 4-43 is a problem from 4.1, section 4.1, that has two cool methods for making factors from imaginary things, which, by the way, folks, it's at 1:15. If you want to leave, you totally can leave. So on that note, I hope your weekend is better than your week was. But for everybody sticking around, I'll continue talking about this. So it outlines two different methods, and I'll try to curate these different methods are here. Actually, you too. Let me pull it out. I see you. Jamboard. All right. So it's recording on the computer, but I'm going to write on my phone. Just because it's a little bit easier to see what I'm pointing out. So there's two methods. So I have this factor and I have this factor, right? So what I need to do is somehow come up with a quadratic. So the first method is to take each root as I have and turn them into factors. The easiest way to do that is just do x minus the root. Okay, so that's why I have x minus 4 minus I and x minus 4 plus I. And then to finish that off, when you multiply it out, again, just be very careful when you multiply it out, but that will give you this. By the way, this is an A right there. Just in case you thought it might be a 9, this is an A. So that's one way that you can work that out. Now, that's one way. And this problem is also another example of the high work versus high elegance. This, again, there's nothing wrong with this method. It's just that it's kind of the high work method because you got to take this, multiply it by that. And if you use the area model, you get a 3x3 that you're multiplying out. So you have 9 terms you have to look at and figure out what's going on with. It totally works. Don't get me wrong. Totally works. Just it takes a little more time to do that part. And that's fine. The other method is this, I'm going to take this one. It's just because I is positive here. And what I'm going to do is get rid of the I is the plan. So to do that, I'm going to come down here. So what I'm going to do is subtract 4 from both sides. So I get x minus 4 equals I. Then to get rid of I, remembering that I is the square root of -1, if I square both sides of this, again, square, square, I get this piece right here. So I get x minus 4 squared equals -1. Now I can go from there. I can multiply that out because, again, I squared equals -1. So I get this. I get x minus 4 squared equals -1. When I multiply this piece out, I get this. And then to finish getting everything on one side, I can add 1 and I get this equation. So whether I make the factors, multiply them out, or take one factor and get rid of the I, one way or the other, I still get to this x squared minus 8x plus 17. So the part to finish here is that we know it goes through the point 4, 1/2. So that's what this part comes in. So now I'm going to plug in, and that's what the red is. Plug in 4 for x and 1/2 for y and solve and see what I get. So when I do that, coming over here, I get 1/2 is y equals a, because it's some stretch value. I just don't know what it is. I have to find out what that value is going to be. And hopefully it'll become apparent pretty soon. So then I have 4 squared, which is 16, minus 8 times 4, which is negative 32, plus 17, which this is negative 16. Negative 16 plus 17 equals 1. So this whole expression right here boils down to positive 1, which then gives us a equals 1/2. So our final answer is right down here in the corner. Y equals 1/2 times x squared minus 8x plus 17. You can multiply that 1/2 through there, or you can just leave it. It doesn't really matter. It's completely up to you how you want to approach it. How does that feel? Does that make sense? What are the further questions you have about that? Woo!